Hi, I'm DJ Ware. On this episode of the CyberGizmo, we're going to be looking at Kubernetes right after this. I've had more than one person ask me to do something about Kubernetes and maybe give an explanation about how to install it. And so today that's what I'm intending to do, but as always, I have to back up for those of you that I don't know who would be in this world that was doing development on containers that didn't know about Kubernetes, but if you're one of them, then this next part is for you. So Kubernetes, what is it? It's a container orchestration system. It allows me to deploy, to initialize, and to set up containers in an environment that has many containers in that I have to manage. It is based on previous versions of software called Borg and Omega, which of course were used by Google. Kubernetes has been in operation at Google for at least 6 years, and today they're using it to spawn billions of containers per week. I mean, that would seriously be a difficult job for even a raft of system engineers to be able to manage, or system administrators to be able to figure out what was going on and when. It was created in the summer of 2014, and its first production grade was released in July of 2015 as version 1.0.1. Currently, we're at version 1.17, and that was as of December 2019. I'm going to be using the latest as of this video, 1.17.3, to show you around the system a little bit. So the base unit of Kubernetes is the pod. It's the basic unit of work in Kubernetes. Pods are one or more containers that share volumes and they share namespaces. So it allows me to install a group of containers that make up an application or a pod. They run temporarily the containers run temporarily in an existing pod. Pods are disposable, they're replaceable, they're scalable. If they crash, they automatically get restarted. But you can't add a container to a pod once it's created. I mean, the only way you can add a container to a pod is if you destroy the pod and then create a new deployment. So just to make things confusing, there is something called an ephemeral container. Don't get ephemeral pods and ephemeral containers mixed up. They're not the same things. And an ephemeral container is an alpha feature that was released with version 1.16, but since I brought it up, I might as well tell you what it is. So ephemeral container, they're not guaranteed any resources or even to be guaranteed to execute at all. They never automatically start. They do not have any exposed ports, and pod resource allocation is disallowed. Wait, so I can't allocate resources. I can't have an exposed port. I can't have it automatically started. What the heck good is this thing? Well, it's useful for interactive troubleshooting when it's needed. And it's generally used by developers, or it's used by a system admin that's trying to troubleshoot a problem with a pod that has crashed. I mean, if I restart the pod, then I've destroyed my runtime environment that may indicate what caused the failure. And also, it allows me to do debugging. So if I have some kind of intermittent problem or I'm having performance issues, it allows me to go and look at a different container that's running in the system and monitor it, take a look at it, run debugging utilities against it, and then get some answers back on what might be happening, what might be going on with the software in that container. And then, of course, you can view processes in other containers so you can see the state of them. You can see how well they're performing. So that's really what it's for. It's a tool. I want to talk a little bit about the architecture of Kubernetes in general. So I suppose the first places to start is with these big green boxes here, nodes, and then we'll kind of work our way around. So, I mean, you can see that there's really two big parts here, right? This is called the control plane. It's also called the node controller. And then, of course, you have the nodes that are the engines that are running the containers that contain the pods that are running in your system. And then there's some management pieces that run alongside it. So this part over here is really the master, if you will. It's really the master of the that manages the various aspects of these two nodes. It first assigns. I won't get into all the technical block, but it assigns a pod to a node. It then brings that pod up, and then there are pieces in here like the kubelet, which monitors what's going on and reports that back to the controller to say, is the state up? Did it crash? What's going on with it? Is it ready to start? Is it, what's going on with it? And then there's some pieces out here that communicate with the cloud API provider. So if you are trying to stand up hardware that is not currently running, it's dark, then the cloud provider can be informed, hey, I need this much hardware resource and I need it stood up. Let me know when it's done. And when it's done, then it will deploy a pod on that node and continue. Then that's part of the scaling that's needed. And also it will release those resources in the cloud when that pod functions are done. So, I mean, in a nutshell, just some other brief things here is you have ECD, which is a database that contains the information about what is deployed and what is deployable. So I'm not going to get too deep into that. There's tons of documentation online that will go through step by step all these things, but this is the thing that we'll be using today to stand up pods within the nodes and to manage them once they're up and running. So I'm just going to keep this simple and real basic. So there's two ways that you can install Kubernetes on Ubuntu 19.10. There's probably 10 other ways, but there's two ways that Ubuntu talks about in their documentation. And the first way is if you want a multi-node setup, that is, you want something that is a production type ready system, you can use something called Charmed Kubernetes that they already have set up for you. But it will take 32 gigabytes of RAM in order to deploy it. That's their recommendation. 256 gig of disk, and SSD is probably going to be recommended for at least that particular portion of it. Now, you could get by with rotational disks. It just depends on how fast you want your response when you start up something. But today we're going to be looking at a single node called Micro K8s, and it uses a whole lot less resources. It uses 4 gig of RAM and less than a gig of disk, and we will be using snaps to do that. So let me go to my full screen here, and we will bring up, I'm going to need another one here, I think. So let me just set this all up. Oops. Okay, so I have my system set up here, and get my cheat sheet up here so I don't skip a step. And then the first thing you'll want to do is you'll want to do a sudo snap install. And I'll have to say classic today because this has changed in 1910 and it requires a different set of rules that it has to apply to that won't allow it to load unless I tell it use the classic mode. In fact, if I attempt to do that without classic, it'll just stop and turn around and tell me, would you use the classic mode, please? All right, so at this point, I need to do one other thing. I need to do a user mod, AG, and then add my user to this group. Now, I've already done that on mine, but once you've done this, you'll need to log out and log back in again for the group to take effect and be activated. But mine, you can see, is already activated here, Micro K8s, and that group gets created at the time that the snap is installed. So that's all set to go. So let's Let's just do a cube control here, which is, remember from the diagram, that's what is controlling my interfaces. And I want to look at all namespaces because I don't know what it's actually created yet. So I'm just going to find out. So it looks like it's defaulted to a namespace called default, which has service Kubernetes in it. It's a type cluster IP. Cluster IP address is there. I have nothing exposed externally, and it's using 443. So this is the internal mechanism for Kubernetes, and that's as far as we have got, or gotten. Next thing I want to do is look at the IP address that is being used by me, which is the Blue Ice client, and it's version 17.3. It's only been around for 56 seconds, so I guess we should get busy and destroy it. No, I'm kidding. Next thing I want to do is I want to enable the DNS and the dashboard. Since I'm going to be using nginx, I want some mechanism for the systems to work. And now I can go back and look at my all namespaces, and I should have a lot more running here. You'll notice that the namespaces now have a pod called Core DNS, a pod called Dashboard. It's added Heapster, and then there's the Kubernetes dashboard and a monitoring pod. Those are all brand new, and you can see it's still coming up. So it's not quite up yet. When they all go running, then we'll be good. Okay, so with that all done, and then these down here are if I have any active ports that are up on the network side of things and what they're doing. Everything looks ready, so I think I can move on to my next step here, which is I'll need to actually run nginx. I want to load nginx onto this cluster. So to do that, we do a cube control again. This time we do run nginx. And I'm going to do 3 replicas of nginx. So let's go ahead and get that started. And then I'll do my namespaces again. And we'll scroll back up here. And you'll see it's in a state that is doing container creation. So I'll need to run that again. I could do a watch and just do this, but this would it's still working on it. So just give it a minute. Well, maybe it's already done. I think that was the previous command. Yeah. All right. So they're all running. I was right. I was in the wrong command. So they're all running. I didn't think it took that long. It's usually pretty quick. So at this point, I need to expose. Because you'll notice right here, there isn't any exposed IP addresses for nginx. So I need to fix that so that we can actually use it from the outside. So to do that, I need to do another micro K8s. And we'll do a cube control. Expose. Deployment is the default deployment, as you can see here. Deployment.apps is what it puts it under. So, and I'll want port 80. And we'll want to target port 80. And then I'll need to tell it that, hey, I'd like this to be part of the cluster IP so that it will load balance between them. The selector is run nginx, and the name is nginx. And if I did that all right, it should have my target exposed now. So instead of doing this, let me just do a get all so we don't need to see all the other things that are running. And this is just going to show me the nginx pods and the services. And this guy right here, I need to capture that IP address because without it, I can't talk to the nginx server. So let's do a wget, and let's just see what comes back here. Yep, we got the welcome to nginx HTML page brought back to us. So we know it's working. Right? So today, so far we have deployed a pod, we brought it up, we've exposed its port, and now we can talk to it, and all is good. So what's next? What are we going to do now? Well, we're going to destroy it. We get it all up and running. We took all this time, and we got it up and running, and now we're going to just destroy it. So to do this, I do a cube control, delete, deployment, nginx. Bye. So now, if I do this, you'll see that my three pods are terminating. The three guys are gone. They're going out. They're out of here. So at some point they should all be gone, and they are. So now they're terminated, and I still have a service that's running down here, service nginx. I want to get rid of that too. So that's next on my list of destruction. And to do that, we use the short form SBC nginx. And hopefully that is now gone. So the system essentially looks a lot like it did when I first installed the snaps for Micro K8s. And I guess you can guess what's coming next. Oh, wait, not quite. I need to bring down, I'm not quite done yet, because did I check my... No, I didn't, did I? Because I still have things running that I need to tear down. So I need to get rid of the core DNS and the dashboard. Those are still running, so I need to get those out of here. For that, we do a disable, and we'll just do dashboard by itself. This will take a little bit. Not too long. This one will take longer because of the replication and the also because of the authorization keys that are used. Yeah, it is an authorization key-based DNS. So I've got to bring all that down. So there goes the authorization, the RBAC controls. And eventually it'll flush the rest of the DNS service out. It's working on it. It's just waiting for these other services to confirm that they're gone. Kind of takes them down in state. So now I just have the service Kubernetes. So now we're really back to where we were when we started. So I need to do a sudo snap remove Micro K8s. And this will take a bit too. It has to disable the service and bring down that service Kubernetes. It also has to clean up all of the junk that we just created by bringing in all the stuff in for nginx, the dashboard, and the DNS. So I'm just going to wait till this is gone. There goes the hook. This is one of the useful things about snaps, is that it's very easy to clean up after something like this. If you were to install this on a system by itself, hello cat, then you'll see that command's not found. So that's really it for what I was going to show today. I know this was brief, but I thought maybe I should probably talk a little bit about, what are some of my thoughts about Kubernetes. And I always have the same pet peeve. So, and it doesn't matter what kind of orchestration it is, whether it's Kubernetes or whether it's VMware or something else. I don't like to see software with schedulers and monitors and being able to launch and start tasks, because the operating system, and manage security, because the operating system already does all that. And so here we are reinventing the wheel to add all these things to orchestration. But there's a good reason why they have to do this with Kubernetes, and that's because the Linux kernel does not have the capability to see inside of a container. It really needs to have that ability. And Docker and LXC and LXD all need to work with that and be able to allow the kernel to be able to see inside the container. If it can, it could then be the scheduler. It then could be the monitor. It then could be the thing that restarts tasks within the container or even the pod itself. But instead, we have to add on this extra layer of software that we really don't want or need in order to manage these containers and pods within our architectures and within our systems. So that's been a pet peeve of mine for a long time. I remember I said that one time about WebSphere a long time ago, and all the people at IBM just looked at me like I was from the moon. But, it's the truth. All these things already exist. Why don't you just use what's already been tested and debugged? Why are you creating something new to do something that already exists? That seems silly. But anyway, I'll get off my high horse, and we'll talk more about Kubernetes. Yes, Kubernetes is very successful as a product. It is widely deployed. It's in tons of organizations. I don't know what the count is, but it has to be in the multi-trillions of containers that it manages today. It is rapidly growing in terms of its feature content and its ability to do more things. My only concern with Kubernetes really is Google itself. Google has a bad habit of when they get bored with a piece of software, they deprecate it. They just throw it to the side and they move on. So I'm hoping that even if they do abandon this, Google has given the source code over to the CNF, which is the Cloud Network Foundation, and they are managing it as a open source project, which is good. That protects us if we're going to use Kubernetes in our environments down the road when Google gets bored and moves on. So that's really my only concern and my only comment with it. Anyway, I hope you enjoyed this today, as always. If there's some comments that you'd like to make in general about Kubernetes, if you're using it or you think you want me to do another video on some other topic within this area, I'll add it to my list, and just let me know in the comments below. As always, I hope you enjoyed this today, and if you did, please like and subscribe. Hope to see you all again real soon, and bye for now.